This is absolutely incredible that people are changing their winter forecast now to a warm and snowless winter. My one question is why, and based off of what data? I have seen people post about the teleconnections. Well, that's great, but the teleconnections are still model runs. So, what are you using observationally? There's very drastic measures going on that are taking place in the upper atmosphere. And I have been tracking this for a while now, and now the response is beginning to happen. If you guys remember, I talked about the albedo effect in Siberia. So let me break out my little bootlegged thing all over again, okay? This is the sun, alright? The sun is beating down, okay? Let's say that this right here is your snow, alright? As the sun comes down with the solar radiation, it bounces off the snow and comes back up. So you kind of have this motion going on like this. Alright? As it's going back into outer space, you have your stratosphere layer. Let's pretend that this is your stratosphere layer right here. Your stratosphere is going to capture and absorb all of the solar radiation. Eventually what's going to happen is it's going to transpire back down to the troposphere, which is your atmosphere. And eventually, it'll work its way up toward the polar vortex in the North Pole. Another thing I'm also going to bring up real quick, and this is going to be a continuation of what I'm talking about as well, is our Rossby waves that are being detected as we speak now. So in plain English, Rossby waves basically form like this. If I were to put a low pressure system right here, and you have a counterclockwise flow, okay? I'm using all red this time. I don't care. If you have bad eyes, that's not my problem. I'm going to put two high pressure systems right here, alright? With a clockwise flow. Okay? If you notice where the two arrows meet, all of this warm air is coming up like this. And it's going to keep on being forced up. And it keeps going. This is where a Rossby wave can form. And it accelerates and keeps going and going and going. Now I will say one thing. I have tried to actually monitor, like, live, real time, the different storm systems. And it is very difficult to do this from scratch. That is, thank God we have models that record data with observations. Because I try to do this, and I'm very theoretical at meteorology, but this is way too hard. I don't think anyone can do that. So, thank God that these models are picking this up. But they're simple, plain English. That's how your Rossby waves form, alright? So if your jet stream's coming down like this, here's your trough, here's your ridge, sharp, there's your contrast, boom, boom, boom. Okay? There you go. Because on this side of the trough, your air is rising. You see this upslope right over here? You're bringing the warm air on this side of the trough, okay? While your cold air comes down like this. Now, I did a horrendous diagram. What we're going to do is we're going to continue with what I'm talking about. So, like I said, I fast forward this at the 240 hours at 30 HBA temperature analysis is showing our Rossby wave pushing up towards the Bering Sea in Siberia and pushing pressure on the polar vortex. One thing that needs to be noted is that you cannot entirely take the polar vortex out of the North Pole, because if you do that, you're going to probably be in an ice age. You will be in a negative 100-degree temperature, probably freezing your ass off. So instead, you break out the anomalies, and you can see these below average height anomalies attack the East Coast, okay? Now, I have evolved to a point with meteorology, theoretical, earth science, all the stuff that I have accumulated over time. The hours no longer scare me. I can literally cheat these models down and figure out what's going to happen without having to be worried about, oh, the hours are so far out. I don't think we should have to play a waiting game anymore. I think we can start attacking things head on more now. If you just put your head and your mind to things and be theoretical about it, it will work, okay? Let's go over to the next thing right here, okay? This is your Southern Oscillation Index in your SOI phase, all right? We have reached our peak with our El Nino, okay? You see this arrow over here? Rapidly rising, all right? And Henry Marcasutti discusses this. El Nino has weakened in November based on the SOI values, but has dipped again the last 7 days. This dip right here, guys, is our final dip. This is where our ENSO peaks, and now it will start to gradually come back up. Or rapidly, actually, I would say, come back up. Transition time in January means winter attacks the east. Snow lovers rejoice. So this is all in perfect timing. And you know what? It couldn't be more, impeccable. So I was tracking these layers and see what was going on and whatnot, okay? So you basically have your 10 HPA and your 70 HPA. So your upper layers, of course, are supposed to be the coldest. Well, this is 10 HPA, and it's negative 36.5 degrees Fahrenheit. So the lower layers should be warmer. No, negative 53.8 degrees Fahrenheit. What's going on right now is our stratospheric warming is starting to take place. Your Rossby wave is bulging up right in this area right over here. All these little, these waves are your Rossby waves ready to form. This one, though, is a fully well-developed Rossby wave right over here. Okay? And it's clearly indicative right in this area over here. As we go past over time, this is going to start to lift up. Okay? These anomalies are going to start to push upward. And all this is going to push up. Once this all reaches the North Pole, that vortex is done. That vortex is going to be shot in this place. Alright? I posted this a couple times because I'm trying to show a lot of people. Our 60-degree temperatures are not only driven by our teleconnections, but our Rossby waves, okay, as you see over here, the anomalies I was showing you before. This is on December 4th, which is now further up north in our latitude. But our southeast ridge and our amplification, the heating, remember, of the stratosphere transpires down to the troposphere, which is your atmosphere. That's why we're going to have 60-something degree possibility that, this upcoming weekend. So because it's going to hit 60 degrees, this is actually the Rossby wave saying, yeah, hi, I'm here to fuck up your winter come January. I hope you like digging yourself out of snow. So, physically speaking, the warmth punches far enough north and displaces the cold. I was having a conversation with some people earlier and explaining, the SST's analogs, which is really, really accurate. And as you can see, it peaks around in December over here, and it begins to weaken as we go forward, which is very, very, very accurate. All right. I just continue. This is not going to be as long as my other videos, but I basically just kind of try to explain to other people the same exact thing. I pretty much just covered the base on the stratospheric warming event coming up, which is actually happening right now. Also, 2 months out, I made a prediction that basically the Great Lakes were going to get screwed over this year. And ABC News makes this tweet: the first time in 116 years, Buffalo, New York has had no measurable snow yet this season, and it's already December. Well, there's a reason for that. No Arctic air intrusions going over the warm lakes is not going to create your heavy lake effect snow. Now, our surface waters in our lakes aren't dealing with Arctic air. It's a Canadian sterile air mass. So as the temperature is slowly dropping, time is running out, because if an Arctic outbreak does slam that area, the lower the lake temperature is, the less snow they're going to get. So their window is honestly going to close quicker than you may think. However, it is very supplemental for an upcoming warm spell, that we're getting this weekend. But still, I think your chances of above average snow, they're pretty much shot. There's, always that possibility, but I would say you have an 85 to 90% chance of getting ripped out. Goodbye. No, not that much snow coming for you guys. Also, I was talking about our transitions actually being shown right over here. Now the lower parts of the California areas are starting to get more precipitation. The jet is starting to, adjust itself, amplify, as per se, with the Pacific jet stream. And I put out a potential winter hotspot. What does this mean? This basically transpires to where the heaviest anomaly-wise snowfall will be. That does not mean that you're going to get the most snow compared to, say, Boston or Portland. It's anomaly-wise. Blizzards, wind speeds, departure from, average. That's what I'm basically articulating. That's pretty much, I think that's pretty much it. All right, you guys have a great day. We're going to see what happens over this next weekend and see what response we get going forward.